Okay, so we're going to talk about cardiac cycle here. And really, we're talking about Wiggers. And I know that we started talking a little bit about Wiggers at the beginning of the semester when I told you review. And so we're going to go into it a little more detail, maybe a little bit different of an explanation, just trying to help you understand what is going on during a cardiac cycle. So we've got 4 phases here, or 4 objectives here. Okay, now if you look online, you read textbooks, oftentimes they actually give you 5 phases of contraction. I like to combine these 2 right here into a single filling. Okay, so we've got filling, isovolumic or isovolumetric contraction, ejection, isovolumetric or isovolumic relaxation. Okay, so we've got isovolumic contraction, ejection, isovolumic relaxation, and filling. Okay, and so here we've got Wiggers. All right, now Wiggers has a lot of information, so much information. Okay, and what it does is it shows the relationship between the volume of the left ventricle, the pressure in the left atrium, left ventricle, and aorta, the EKG or ECG, heart valves, and heart sounds. Okay, so here's volume, here's pressure, here's our ECG, here's our heart valves right here, and then here are the heart sounds. I probably should have put those in order. So I'm going to, as we go through this, I want you to think for a minute. I'm going to ask you a few thought questions, okay? And so obviously you're not here to answer them, but I want you to try and think about this as you go through. So what is happening to left ventricular pressure during each of these phases? Okay, so pressure increases during contraction. It increases followed by a decrease during ejection. We have an decrease during relaxation, and then we have an increase during filling. So the next thing I want you to do is think about, well, what causes each of these changes? Well, isovolumic contraction, pressure increases because the ventricle is contracting. You're going to hear me talk about in class, and if you've had me before, you have heard me, compare this to a water balloon. What are the 2 ways you can increase pressure in a water balloon? Well, one of those ways is if you just squeeze the water balloon. Okay, and the other way is if you fill up the water balloon, put more water in it. During ejection, it increases and then decreases. Well, the initial increase is due to the contraction of the ventricle. It's still continuing, okay, but it's decreasing due to the decreased left ventricular volume. Now, during the second half when pressure is decreasing, it's important to remember that the ventricle is still contracting, but because so much blood has been emptied out of it, that offsets the increased pressure due to contraction. During relaxation, it decreases because the ventricle is relaxing. But filling, there's an increase due to blood coming from the left atrium into the ventricle. So you have an initial large increase in pressure due to that AV valve opening, dumping a whole bunch of blood in. That slows down as our gradient reduces. But then you have a large increase, a large spike at the end due to atrial contraction. Okay, so that's pressure. Now let's talk about volume. And we've already talked about it, but let's go through this. So what happens to volume during each of these phases? Well, during isovolumic contraction, it's constant. Ejection, it's decreasing. Isovolumic relaxation, it's constant. Filling, it's increasing. So what's causing these changes? Okay, well, during isovolumic contraction, all the valves are closed, so blood can't leave. That's why we call isovolumic or isovolumetric. So if you've got isovolumic or isovolumetric, the valves are all closed. Blood has nowhere to go. During ejection, that aortic valve opens, so blood's leaving through the aortic valve going into the aorta. During isovolumic relaxation, everything's closed, so nothing can come in, nothing can get out. And during filling, the AV valves open, so blood enters the ventricle from the atrium. So now let's tie this into the ECG. What happens to the ECG during each of these phases? Well, isovolumic contraction is where ventricular contraction starts, and so that's when the depolarization of the ventricle occurs, so that QRS. During ejection, there's nothing really, it's kind of gets into the end of the QRS, but isovolumic relaxation is where we have the T wave, that's where the ventricular repolarization begins. And during filling, we have the P wave, and this is caused by atrial contraction. I forgot that I had this next slide, right? So remember, this is QRS, T, sorry, that's terrible, and P. All right. So when do these heart valves open and close? And I want you to think about when these valves open or close, that's how we're ending one phase and going to another. So at the end of isovolumic contraction, the semilunar valves open. At the end of ejection, those valves close. At the end of isovolumic relaxation, the AV valves open. And at the end of filling, they close. And remember, this is a cycle. And so after this, we come back here, right? So you open a set and then close that set. And then you open the other set and close that set. And it keeps going on and on and on. So what's causing these? All right, weird animation. Sorry about that. So during isovolumic contraction, the semilunar valve opens because ventricular pressure exceeds aortic pressure. During ejection, ventricular pressure falls below aortic pressure, which causes or allows that semilunar valve to close. During isovolumic relaxation, at the end of it, remember this is at the end of each of these phases, the AV opens because atrial pressure, due to the filling of the atrium, increases above ventricular pressure. Okay, this valve does not open due to atrial contraction. It's opening because the atria are constantly filling with blood. So we're increasing the pressure. There's nothing to prevent blood flow into the atrium. And then during filling, at the end of that AV valve closes. This should say AV valve closes because atrial pressure falls below ventricular pressure. So the last thing is, when do these heart sounds occur? Well, at the end of isovolumic contraction, there's nothing because valves are opening. At the end of ejection, we have the second heart sound, which is dub. Okay, so that's the closing of the semilunar valves. All right. At the end of isovolumic relaxation, there's nothing. At the end of filling, we have the first sound, or lub. So what's causing these changes? And again, sorry about the weird animations here. Isovolumic, there was no sounds. In both cases, ejection, you've got semilunar closing, and during filling, you've got AV closing. And so that is Wiggers in a different way of looking at it. And we'll talk about it in class and have some activities.